Hi everybody, today I'll be walking you through my Excel sheet. For my Excel formulas, I just input what I want to put inside my calculations according to the row and columns of the cell. So this cell right here, B12 plus F4 times A12 plus H4. Equal is just equal, plus is just plus, multiplication is represented by an asterisk. Dollar signs in front of the row and column is to make sure that the value remains absolute while the rest of the cells in the equation continue being relative. I do a little drag so that my equation can be carried down the whole column. For my question 3, I just sub in my B and C using the cells that contain the value I want for both the discriminant and finding the x with quadratic formula. My A is 1 because x squared has an invisible 1 in front of it. Finding x, I input the b squared minus 4ac directly into the equation from the discriminant at cell M11 where we found earlier. In Excel sheet, minus is represented by the dash symbol and division is represented by the slash symbol. Respectively, my B and C is 4 and 3. This graph represents our y outputs. Here we have a bigger same exact graph for reference. To answer my question 4, the completed square formula is applied to determine the shift after substituting my B and C accordingly. How to find the graph shift from a completed square form? The vertical shift is shown by finding the k outside of the function x. The k will be everything outside of function x, which is outside the bracket. When k is more than 0, the graph will move up, and if k is less than 0, the graph will move down. So our k here will be negative 1. It is less than 0, so the graph shifts down by 1 unit. This is because for the graph to return to the original x square graph, you will have to subtract 2 out of the entire function. Next, the horizontal shift is shown by the x inside of the function, x plus k, which is inside the bracket. To find this k, you have to focus on what is inside and ignore everything outside of it. For the horizontal shift, if k is more than 0, the graph will move left. And if k is less than 0, the graph will move right. In my case, my k for horizontal shift is 2. 2 is more than 0, so my graph will move left by 2 units. This is because to get back to the original x square graph, you have to plus the 2 back inside of the function. Combining my input and output shift, you can see the graph movement from y equal x squared to y equal x squared plus 4x plus 3. Go down by 1 unit and move left by 2 units. The main takeaway of question 4 is that you can change the equation using the completed square formula, so that you can tell how the graph shifts around the x and y axis depending on the values of k inside and outside of function x. Now I will move on to question 5. The discriminant is derived from the formula b squared minus 4ac. The answers for x can be very different depending on the discriminant. The scenario is you have 2 real solutions if your discriminant is more than 0. Using my b and c values, 4 and 3 respectively, the discriminant will be 4, which is more than 0. So if you work it out manually using quadratic formula, you'll get 2 answers for x intersections, -1 and -3. That will be correct because the graph cuts the x-axis at 2 points, -1, -3. Second scenario is you will have 1 real solution if your discriminant equals to 0. For example, x squared. The discriminant is 0 because the b and c are both 0. They are invisible as writing 0x plus 0 is unethical. Once the quadratic formula is applied, there is only one singular real answer, x equals 0. That is the case because the graph only touches the x-axis one time at x equals 0. The last scenario is that you will have no real solutions, or rather 2 complex or imaginary solutions. Let's use b equal 3 and c equal 5 as an example. After using b squared minus 4ac to find the discriminant, we will get -11. Once you start to manually apply the quadratic formula to find the x-intercept, you will realize that you cannot square a negative number. So imaginary numbers are used to solve for x. X will only equalize to 2 imaginary answers. On my Excel sheet, if you sub b with 3 and then you sub c with 5, the x will show #num exclamation, which means that the x does not recognize that function, since the answers will contain imaginary numbers, because the graph does not touch the x-axis at all, meaning no intercept. Thus, there will be no real solutions if the discriminant is less than 0. In conclusion, by seeing the value of the discriminant, you should be able to tell how many solutions for x. Just by looking at the graph, you should also be able to tell the amount of time the graph intersects x.